Today we are going to look at solving equations with variables on both sides. So we're adding variables on both sides, and this is going to be page 32. So pause it if you need to add that. And then in our notebook, we should have a foldable. So when we cut along the dash lines, we get something that flaps out like this, and then we're gluing it down where it says glue here. Okay, and then our full sheet's going over here. So pause if you need to do that. However, before we finish filling in these notes, we're going to go back to yesterday and fill in the info that we had from yesterday. So yesterday we skipped this step 3. Okay, we said nothing would happen with this step 3. Well, now today something has happened. So is happening. So that's what we want to fill in here. Okay, so in step 3, we are going to add if there are variables on both sides of the equal sign. Okay, so if we see variables on both sides of the equal sign, then we need to get them together on one side. Okay, and the way that we move things across the equal sign, what we've always done is we move with the opposite sign. So this is different than combining like terms, right? If we're combining like terms, we're looking at the sign that's directly in front of it and we're just bringing them together. On this step here, we want to make sure that we are getting them together with the opposite sign. So we're looking at that sign in front of it, and then we're using the opposite sign of it. Okay, so if we have something like 8w plus 6 equals 2w minus 4, we see that we have variables on both sides, right? We have one on the right-hand side and we have one on the left-hand side. So to get those together, we need to use the inverse operation or the opposite operation. You can decide to move whichever one that you want to move, though my suggestion is to help keep it a little bit simplified. There's two sort of things we want to look at, and we're going to talk about both of them. The first one is that whichever is smaller is usually the easier one to move. So because 2w is smaller than 8w, right, we're going to look in front that 2w is positive, and the opposite of a positive is a negative. So I'm going to use a negative 2w. Now notice I'm not writing it randomly anywhere. I'm writing it underneath the w's on both sides. Okay, so an 8w minus a 2w gives me a 6w. That plus 6 is coming down. And these two w's cancel out, so all I have left is a negative 4. Just like we've done before, that sign in front is still part of it. Okay, and now we're down to just a basic 2-step. So this is something we can now solve. So we can undo addition with subtraction. Right, a negative 4 minus 6 gives us a negative 10. And then we can undo multiplication with division. Again, getting an answer that's a fraction is fine. We just always need to make sure it's in its simplified format. So negative 10 over 6 isn't reduced. So we would either need to turn this into a negative 5 over 3, a negative 1 2/3. That's a 0.6 repeating, so you'd have to have that repeating bar. Okay, all of these other steps that were already on this page still apply today. So we can still go through all of these steps when we're trying to solve. Okay, so that being said, I want to take a look at this first one. I know we still have these flaps over here. We're going to get to those in just a second. I want to take a look at this first problem over here. So if we take a look at the first one, this does have variables on both sides. Okay, there's no parentheses, so we don't have to worry about distributing. There's no like terms to combine. We just have to get the variables together. Now, this time the 4w is smaller than the 6w. Okay, so it might be a better option to move that 4w. So the opposite of a positive or the inverse of a positive is a negative. So I'm going to subtract that 4w over. So these cancel out. This is going to leave me with a negative 8. 6 minus 4 is a 2w plus 22. Okay, now I'm down to a 2-step equation. Or if you don't remember, right, you can go back over to your steps over here. We don't have a large fraction, so now we're going to deal with addition and subtraction. So we'll undo adding 22 by subtracting 22. And then we will undo multiplying by 2 by dividing by 2. So we'll get negative 15 equals W, or W equals negative 15. Okay, if we look at this second one here. Okay, so we go down our list, right? Are there parentheses? The same things we were doing yesterday. Yes, there are parentheses, so we are going to want to distribute. So 5 times S is 5S. 5 times negative 11 is a negative 55. Okay, this other side is staying the same because there's no parentheses over here to deal with. Our next step says combine any like terms. So if you have any like terms, we can combine them. So on this side, we don't have any like terms, but on this side we do, right? We have an S here and an S here. Those are on the same side of the equal sign. So we are combining them with our same rules using the same sign, right? Same side of the equal sign. We're using the same sign when we get them together. So an 8S minus a 6S, because we're using that one in front, is a 2S. And that negative 14 is just coming straight down. Okay, then we're going to move on to our next step. Our next step says if there are variables on both sides, we need to combine those. We need to get those together, right? And when they're on opposite sides of the equal sign, we need to get them together with the opposite sign. Okay, so again, my suggestion is to move whichever one is smaller. So 2S is the smaller one. Okay, so this is a positive 2S. So I'm going to subtract 2S. Again, I'm writing it underneath the S's, nowhere else, just underneath those like terms. So 5S minus 2S gives me 3S. That minus 55 is coming straight down. At this point, I'm just down to a two-step equation, so we're good to go here. So we can undo subtraction with addition. Okay, and that's going to give us a 41. When we divide by 3 on this one, we are not going to get something that divides evenly, nor can it be reduced or simplified. So we could say S equals 41 over 3. You could turn this into a 13 2/3. I guess 13.6 repeating, but again, same statement I've been saying, you have to have that repeating bar. Okay, so if we look at this third one here, 5R equals 3R plus 7R minus 32. Okay, so step number 1 says, if there are parentheses, distribute. No parentheses, so we don't have to do that. Step number 2 says, if there are like terms, combine them. Okay, so we do have like terms over here. They're on the same side, so we're using the same sign. So 3R plus 7R gives us a 10R minus 32. Now, I told you over here when we were filling up the step, there was 2 things to consider when getting those variables together. Here's our second thing. Okay, yes, we have variables on both sides. Yes, typically it's easier to move the smaller one, but that's not foolproof. Okay, which is why I didn't put in there a permanent rule of saying do that. Because the other rule that we want to make sure is that we never empty a side. Now, could we move this 5R? Yes, but that would leave this side with 0, and we just have to move something back over. Okay, so we really don't ever want to empty a side. We don't want to make a side have nothing. So if I move this 5R, there's nothing left over there, and that's not helpful. Okay, so in this situation, our hands are a little bit tied. So even though 5R is smaller, moving 5R would empty that side. So we're going to move this 10R instead. The 10R is positive, so we are going to subtract it. 5R minus 10R gives me a negative 5R. Okay, we are going to divide both sides then by negative 5. Now, here we get a fraction, which is fine, but we do need to make sure, even though I can't necessarily reduce this, we do need to make sure that 2 negatives make a positive. Okay, here's one that most of you would probably more likely go to a 6.4, okay, but you could leave it as 32 over 5, or you could leave it as 6 2/5. Okay, now, We then have an interesting idea that we also need to talk about that happens once we allow variables on both sides. Okay, and that's that we can get solutions, answers that are either no solutions or all real numbers. Okay, and in this situation, to get a no solution or all real numbers, we are going to be in this situation that if the variable cancels out and you are left with a false statement, something that's not true, our answer is going to be no solution. Okay, and here's what I mean by that. So if we look at this problem right here, this 6y minus 5 minus 2y equals 2 times 2y plus 6, right? We go through our steps. The first thing that we're going to do is distribute. So this gives me a 4y plus 12. Okay, over here I combine like terms because they're on this same side and they're like terms. So 6y minus 2y gives me a 4y. Okay, at this point when I say, okay, well, which one's smaller? Well, I mean, both of the variables are the same, so it doesn't matter which one I move. And when I move them, they both cancel each other out. So the only thing that I'm left with is negative 5 equals 12. Okay, and if we ask ourselves, does negative 5 equals 12? This is not true. This is a false statement. So our answer on this one would be no solution. That means that there is no value that we could pick that would make this equation true. Whereas on the flip side of this, we could also get an answer that's in all real numbers. Okay, and this says that if the variable cancels out and we are left with a true statement, okay, then our answer is going to be all real numbers. Okay, so same idea. If we look at this one, we distribute. 4 times x is 4x minus 28. I mean, we can already really see it right here, right? 4x minus 28 equals 4x minus 28. But if we do go to get our variables together, right, these cancel each other out and we're left with negative 28 equals negative 28. And this is a true statement, right? Negative 28 does equal negative 28, so our answer is going to be all real numbers. This means that we could pick anything. We could pick anything to be our answer, and it would work. Okay, so if we look at these last couple over here, okay, we have 11y minus 17 equals 5 times 2y minus 7. So right there we see those parentheses. Parentheses tell us to distribute. So that gives us a 10y minus 35. Everything else is coming straight down. Then we have some like terms that we can combine. So 10y plus a y gives us 11y. We have variables on both sides. So I'm going to move a positive, right? One's not smaller than the other, so here's where we know we're going to be in that situation because they're the same. So we get negative 17 equals negative 35. That is not true, right? This is a false statement. Negative 17 does not equal negative 35, so our answer for this one is no solution. Okay, and this is actually what we say our answer is. That's what we have to write down as our answer. And then our very last problem down here, okay, so we have parentheses. We are going to distribute. Okay, over here we do have like terms. Okay, so they're on the same side, so we are using the same sign. So 17 minus 5. Right, we can already kind of recognize they're the same, but if we get those variables together, our C's cancel. 6 equals 6 is a true statement, and so our answer for this one will be all real numbers.